Question. As we discuss how to work out the volume of this, because for us 2D figure is given, but actually it's like 3D. That is what the face we'll see from the top, and it will have a thickness. So we work out the volume of this part we call V1, which is equals to pi d square by 8 into the total thickness. And we work out the volume of this part, which is V2, that is x multiplied by d, length multiplied by width multiplied by t. So that will give us the volume of a rectangular part. And another thing which is important is like unit conversion. As you can see, we want the volume in centimeter cube. These units are in millimeter, so we have to convert first into centimeter before substituting that in our formula. So we have to show that the volume is about 6.2. So when we add them at the last V1 plus V2, we will get this total volume. The next is show that the uncertainty is about 0.2. How to work out the uncertainty? How we got the volume? As you can see, we got the volume by V1 and V2. So the total volume V we got by some addition of V1 and V2. How we got V1? V1 is actually pi d square by 8 into t. So means the percentage uncertainty in V1 will be equal, because 8 and pi are constant. So it will be 6.24. Okay. So the percentage uncertainty in V1 will be twice the percentage uncertainty in D plus the percentage uncertainty in T. Even quantities are added, multiplied, subtracted. Anything happen to the quantity, the percentage uncertainty will always add. So this will give us a percentage uncertainty in V1. And how to get the percentage uncertainty in V2? The percentage uncertainty in V2 is calculated by, so it will x, d and t. So it will be a percentage uncertainty in x plus the percentage uncertainty in d plus the percentage uncertainty in t. We'll add them, we'll get the percentage uncertainty in V2. Yes, sure, I will repeat the part for the percent uncertainties. Look, the question is show that the uncertainty in the volume is about 0.2. Okay. How we calculated the volume? We calculated the volume by adding the two volumes, two separate volume V1 and V2. How V1 was calculated? V1 was calculated by using a formula pi d square, means that pi d square times t divided by 8. And how V2 is calculated? By multiplying x with d with t. So how total volume is calculated? Total volume is calculated by adding V1 and V2. So what will the percentage uncertainty in the V? The percentage uncertainty in V is equals to percentage uncertainty in V1 plus the percentage uncertainty in V2. That will be the total uncertainty, the percentage uncertainty in total volume. But how the total percentage, how V1 is calculated? V1 is calculated by a formula. V1 is calculated by a formula. So if I need the percentage uncertainty in V1, V1 is calculated by a formula pi. Pi does not have any uncertainty. 8 does not have. D is having uncertainty, but it is a D square. So it will be percentage uncertainty in D multiplied by 2. Why multiplied by 2? Because if the power 2 is there, it will be times 2. If power 3 is there, and then there's also a T is there in the, it's multiplied, but the percentage uncertainty always adds. So it will be equals to percentage uncertainty in T. That's how we get the percentage uncertainty in V1. Is it clear? This part? Do we need to convert the units? No, when you are taking a percentage uncertainty, no need for conversion of units. Because a percentage does not make difference. Like if I use both units in centimeter, both in millimeter, I don't have to convert the units. It won't make difference. Like if I have like 1 millimeter over 10 and I convert both of them in centimeter and use a percentage, I'll get the same answer. So when you are working out the percentage uncertainty, no need for unit conversions. So what is the percentage uncertainty in D? The uncertainty in D is 0.05. So 0.05 and the value recorded is 10.10. Multiply by 100, multiply by 2. Plus, what is the percentage uncertainty in T? 0.02 divided by 1.40, multiply by 100. So what is the percentage uncertainty in V1? 2.4. So we write 2.4% is the uncertainty in the value for V1. Now, the percentage uncertainty in V2. The percentage uncertainty in V2, can we use a fractional uncertainty? No, you cannot use a fractional uncertainty. What is the reason? Because the quantities are multiplied here. When quantities are multiplied, you cannot add the fractional uncertainties. In that case, it must be a percentage uncertainty. Fractional uncertainty is only possible if quantities are added or subtracted. That time you can use a fractional uncertainty. Then what is the percentage uncertainty in V2? Percentage uncertainty in V2 is the uncertainty in X plus the uncertainty in D plus the uncertainty in T. But you said, yeah, I said uncertainty always add the percentage. When I mean uncertainty always add, I mean percentage uncertainties. If the units were same for the quantities, then we can add the percentage uncertainties as well. But that is when the quantities are added or subtracted. When they are multiplied or divided, in that case, only thing what you have to do, the percentage uncertainty you have to add. So uncertainty in X, it will be 0.1 divided by 4.5 into 100. Uncertainty in D is 0.05 divided by 10.10 into 100. And uncertainty in T, it is 0.02 divided by 1.40 into 100. So that will give us a percentage uncertainty, 4.14%. Now, what is the total uncertainty in V? Because it is calculated by V1 and V2. So uncertainty in V1 is 2.4 and uncertainty, this was 4.14. So we got 6.14%. 6.54%. Now, but we need the absolute uncertainty. So what is 6.54% of the total volume? Like our total volume was what? You mentioned that 2.64, 6.24 cm cube was a total volume. So what is 6.54% of this? So 6.54 multiplied by 6.24 divided by 100. What's the answer? 6.54 times 6.24 divided by 100. What's the answer? So this will give us the absolute value, which is 0.16 cm cube. Then the student determined the density and the percentage uncertainty is 3%. The accepted value for a prefix is 1.18. Explain whether the student suggests that the protector could be made of the prefix and your. So what we have to do, we'll work out the percentage difference. The determined density is 1.04. So we'll work out the percentage difference here. Percentage difference will be the maximum minus minimum divided by mean, or the standard value. So maximum is 1.18, minimum is 1.04 divided by standard 1.18 into 100. So the percentage difference is coming out 12%, where the percentage uncertainty was 3%. So percentage difference is greater than, so it is not made above the perfect. So percentage difference is greater than percentage uncertainty.